Bismillahirrahmanirrahim. Assalamu alaikum. In this video, we are going to talk about anesthesia machine, basically the equipment that are used while using or working with gaseous anesthesia. So you can see this picture. Basically, this picture is from Veterinary Anesthesia by Lemon Jones' book, and this picture shows each and every part of an anesthetic machine, and we are going to see what is each part and what functions do it perform. So our first part of lecture is on the components of an anesthetic machine. First thing over here is that an anesthetic machine is having three parts. The first part is oxygen supply cylinders or the central lines from where the oxygen is supplied to the anesthetic machine in the operation room. So, in this whole diagram, you can see this first portion that includes the oxygen cylinder along with its gauge. So, this portion is included in the first part, that is oxygen supply cylinders or central line. Basically, the difference between cylinder and central line is same as we have gas supplies in our kitchens. Like we have a central line of central pipeline of gas that is basically given by the government in each house. But once we run out of that gas, we have small cylinders which we use if the gas from the government is not being available. So it's the same. Either you use a central supply line of the hospital, or you are using the supply cylinders. Next portion is an aesthetic machine. It includes all of these parts like regulators, flow meters, vaporizers, common gas outlet, oxygen flush valve. We will study what are the functions of each of these parts, but this portion basically comprises of an anesthetic machine. This is the third part. This is called as breathing circuit. Here is your patient. This portion will be connected to the mouth of the patient through like those either by endotracheal tube or by face masks that are being used. So starting with the component first component is the oxygen cylinder, which is the source of oxygen. Basically, normally oxygen cylinders are whitish in color, but you should be aware that sometimes people or in different countries the color might vary. So it is preferable to read the label on the cylinders rather than just relying on their colors. Because each gas has different color, like oxygen has white, nitrogen, carbon dioxide, all those gases have different colors. But still, you should not rely on the color only, read the label also. Next part we have is the gauge. Gauge is basically the pressure gauge that measures the pressure at 3 points. Number one, gas cylinders, anesthetic machine, and breathing systems. Basically, at all those areas there is a gauge being fixed in the machines. So this the purpose of gauge is to measure the pressure. Like you can see a gauge over here, the actual image of the gauge. Then we have the hanger yoke. Hanger yoke, this is called as hanger yoke, or I have placed this picture too. This is a hanger yoke. Basically, hanger yoke, this oxygen cylinder is attached to this anesthetic machine through this hanger yoke. This hanger yoke causes a gas tight seal and ensures a unidirectional flow of gases to the machine, so that it ensures that the gas from the oxygen cylinder goes in unidirectional flow and there is no leakage in between. Next we have is a regulator. A regulator is a pressure reducing valve that is used to bring high pressure of gas cylinders down to a more reasonable and safe working pressure. It means that the pressure inside the gas cylinder is so high that is dangerous for the patient. So we have a regulator over here that will bring this pressure down to a safe level. And when we have talked about this pressure over here, so let's see one more thing about pressure, that as per the pressure is concerned of the gas throughout this anesthetic circuit, the whole this image is basically divided into three parts. um, we have high pressure areas, intermediate pressure areas, and then we have lower pressure areas. This green portion that includes oxygen cylinder, this gauge and regulator, this area comprises of high pressure area. Then we have flow meter, oxygen flush valve. This area includes intermediate pressure area. Then we have vaporizer of outlets and all this breathing circuit. This whole area, the gas runs in this area is of low pressure. So this is the low pressure area. So let's see. In the high pressure area, it accepts gas at cylinder pressures and reduces and regulates the pressure. So the this area basically is accepting gas from gas cylinder, and that has a very high pressure. And the areas are included in this are gas cylinders, hanger yokis, high pressure hoses, and regulators. So till the regulators, you have the high pressure area, and the pressure over here is 2200 psi. Then we have intermediate pressure areas that accept gases from central pipeline or from regulators on anesthesia machine and conducts them to flush valve and flow meter. It includes area pipeline inlets, flow meters, oxygen flush separators, and it has pressure of 40 to 55 psi. So it is basically talking about this area, that it has intermediate pressure because this regulator has reduced the high pressure to intermediate pressure. Next we have is low pressure area, that consists of conduits and components of between flow meter and common gas outlet. Includes vaporizer, piping from flow meters to vaporizers, conduit from vaporizer to common gas outlet, and breathing system. Here the pressure is close to ambient pressure, because here pressure should never exceed 30 cm of water, as these pressures are transmitted directly to the patient's lungs. So that is why this area is specifically having low pressure, because the gas from here is directly going into the patient's lung. So if this area is going to have high pressure, then it will be dangerous for the patient. So the pressure over here should be close to ambient pressure, that is the atmospheric pressure in which animal normally breathes in. So that was all about this regulator. So regulator is a pressure reducing valve. It will reduce the pressure to the more reasonable and safe working a pressure. Next we have is a flow meter. Flow meters controls the rate of gas delivery to low pressure area of an anesthetic machine and determine fresh gas flow to anesthesia. So basically, this flow meter has the role that it controls the rate of the gas delivery. The pressure was regulated or controlled by regulator, but the rate of that gas is controlled by the flow meter. And there is a separate flow meter for each type of gas used, and gas enters from bottom and exits from the top. Let me show you what does this mean. So see first, this diagram, you see over here, this is blue and this is green. So I guess the blue is used for oxygen and green is used for nitrogen gas. So each gas has a different flow meter, and there is this diagram. Basically this flow meter, the inside of this flow meter is like this. It has a tapering shape, like it's narrower from the bottom and wide from the top, and the gas flows from lower portion and goes out from the upper portion, and there is a ball in between like this. You can see this ball over here and this ball over here, and basically it tells you the rate at which this gas is moving. uh, So basically, flow meter controls the rate of gas delivery to this low pressure area of the anesthetic machine. And separate flow meter for each type of the gas. Gas enters from the bottom and exits from the top. Next we have is vaporizer. Vaporizer is very easy. It changes liquid anesthesia into the vapor and measures the amount of vapor leaving the vaporizer. So it changes the liquid anesthesia into the gaseous one. Basically, gaseous anesthesia itself comes in the form of liquid, but this vaporizer converts it into the gas form. Temperature, pressure, and flow rates alter vaporizer output. So you should know these three parameters will alter the output. Next we have is the flow rate. Flow rate at which the flow rate is the rate at which gas flows and is controlled by the flow meter. So this flow meter basically controls the rate at which the gas flows. Changes in the flow rate through vaporizer changes in the output. So if the rate of the gas flow through this vaporizer is changed, the output is changed. Because if there is a high flow rate, then there will be incomplete saturation of gas moving from the vaporizing chamber and there will be reduced output. Let me explain you what does this mean. That oxygen from this cylinder will move from here through the regulator and it will come in the vaporizer. Already in the vaporizer there is liquid anesthesia being placed. This liquid anesthesia is being converted into gaseous anesthesia and get mixed with this oxygen that comes from this cylinder. So now here the oxygen gas gets mixed with the gaseous anesthesia and comes from here and enters into the patient breathing circuit. So, if the flow of oxygen through the vaporizer is very fast, then the vaporizer gets less time to saturate the oxygen gas with the gaseous anesthesia. But if the flow rate is low, the more gas gets more time to get saturated with the or mixed with the gaseous anesthesia. So low flow rates will have high output of gaseous anesthesia, but high flow rates will have low output of the gaseous anesthesia. And clinically useful flow rate is 500 to 2000 ml per minute. I hope you have understood this flow rate. Next we have is oxygen flush valve. First, you should know that it is not present in all machines, and if present, it is designed to rapidly deliver large volumes of pure oxygen, non-anesthetic gas to patient breathing circuit in emergency situation. Basically, what happens normally, you have this when this apparatus is working, the oxygen gas gets mixed with this gaseous anesthesia and keeps the patient in unconscious situation. But let's suppose you see that your patient is getting into deep anesthetic plane or deep anesthesia stage, and or uh, or not only in that situation, even if like your patient is about to die and you think you should stop your surgery there and you want to stop the gaseous anesthesia and you want your patient should be receiving only and only pure oxygen gas. So you press this button, and as this button is pressed, the gas starts to flow from cylinder through this pathway into the patient breathing circuit, and the gas will bypass the flow meter, it will bypass the vaporizer. So the pure oxygen will flow into the breathing circuit and into the patient. And with that, patient will start to wake up because now no gaseous anesthesia is being delivered to the patient. Next is common gas outlet. Common gas outlet basically connects an anesthetic machine to breathing circuit. Okay, this is the anesthetic machine and this is the breathing circuit all over here. So this connects them both. And gas reaching common gas outlet has traveled from gas supply through regulator, flow meter or vaporizer. This is very simple thing. They are telling that the gas that reaches over here is basically traveled through regulator, flow meter and this vaporizer, and then it enters here. gas flowing from common gas outlet delivers anesthesia and carrier gas both to the patient circuit at concentration and flow rate that are determined by vaporizer setting and flow meter flow rate. So simple is that it travels from these areas, and the rate at which it is being traveled is also controlled by, we have already learned in the previous slides that that rate is determined or controlled by flow meter and this vaporizer. So that is only thing about common gas outlet. Next, we have carbon dioxide absorbent canister. Basically, it is a chemical that absorbs exhaled carbon dioxide. Um, because you can see over here that when the gas comes out of common gas outlet, it moves through this direction into the patient uh, during inspiration, and during expiration animal breathes out, and the gas along the carbon dioxide is being carbon dioxide moves in this circuit and it comes to this direction, and this is the carbon dioxide absorbent canister. It has uh, s- carbon dioxide absorbents like whole, and these absorbents are basically either soda lime, bara lime, or M-sorb lime, but soda lime is most commonly used, so we will remember only the soda lime. So it has soda lime in it, and this soda lime will absorb all the carbon dioxide. And the principle of the carbon dioxide absorption is simple, that involves a base absorbent, that is soda lime, that that neutralizes the acid, that is carbon dioxide. Carbon dioxide is considered as an acid, so the base will neutralize the acid, and end products are water, carbonate, and heat. There are one or more things about carbon dioxide canister are that fresh soda lime is always white and can be crushed easily. Exhausted soda lime is off white and is hard, can't be crushed. Color, when the fresh soda lime is like, you see it is white and it changes its color to either off white or purple or violet. But it is said that granules basically contain a pH sensitive dye, so color itself is not important, like which color it is changing, but the important thing is color should change. The change in color is important, but to which color it is changing is not important. Next, when soda lime is exhausted and unable to absorb more carbon dioxide, end tidal volume increases on capnography, because when you are using these anesthetic machines, you are also using capnography and pulse oximetry, like all of those settings you have attached to your patient and recording different parameters, oxygen level, like pulse oximetry will tell you the oxygen saturation, capnography will tell you the end tidal carbon dioxide level. So basically they are saying that measuring or seeing the carbon dioxide level through capnography is far better way rather than seeing the color change of the granules, because color change in granules is not acceptable way of identifying the exhaustion of the carbon dioxide canister. Rather than you should preferably see the end tidal carbon dioxide level on the capnography, so that is more preferred way. But still when the soda lime gets exhausted, its color changes. Dispose the wasted or exhausted soda lime in the trash. Soda lime life is dependent on flow rate. If the flow rate is high, granules deplete more quickly. If the flow rate is lower, the granules will deplete slowly. So that was all about simple carbon dioxide canister or absorbers. Next, we have is scavenging system. Scavenging system basically removes the waste and static gas from breathing circuit to outside of the building or into the charcoal canister. So basically, there are charcoal canisters like this attached with the anesthetic machine, and what happens that either this charcoal um, absorbs the waste in a machine that are being present in the operation room, or there is there is some another system through which scavenging system through which the waste and static gases are thrown outside the building. And you about this charcoal, you should change the charcoal with when its weight increases 50 gram. So whatsoever, like if it's 100 gram in weight and it gets to 150 gram in weight, change it, because that has fully used, or that is exhausted. So basically scavenging system is to remove waste and static gases, and it is important to protect the doctors. Otherwise, if the extra amount of anesthetic gas gets accumulated within the room, the doctors will also start to faint and go unconscious. Then we have the reservoir bag. Reservoir bag is referred as breathing or rebreathing bag. It is collapsible container which permits manual ventilation. Basically, this is the reservoir bag, and it is also called as breathing or rebreathing bag. It is filled with the gas, and if your animal is in any emergency situation, you can press this bag to increase the ventilation of the animal. That will be a manual ventilation. It also acts as visual or tactile indicator of spontaneous breathing by changing its volume with patient's expiration and inspiration. So when the patient is like unconscious under surgery, and the patient is breathing, as the patient will inspire, it will this anesthetic bag will go bit flat like this, and when the patient will exhale, it will again like bulge out like this way. So it will change its volume with patient's inspiration and expiration. It is recommended that the rebreathing bag have volume of approximately 5 to 10 times of patient's normal tidal volume, or roughly equivalent to patient's minute volume. So that is not a important thing to remember so far, but it should have like 5 to 10x of patient's normal tidal volume. Next we have is fresh gas inlet. Fresh gas inlet is the site of gas delivery to the circulating system from common gas outlet of the anesthesia machine. Fresh gas inlet is normally found after carbon dioxide absorbent and before inspiratory one-way valve. So um, this is common gas inlet or fresh gas inlet, and it comes after common gas outlet, or even they have said that it is found between or after carbon dioxide canister. This is carbon dioxide canister, so it is present after carbon dioxide canister, and it is inspiratory one-way valve, so it is present before inspiratory one-way valve, because the direction of this breathing circuit is like this. So it comes after canister and before inspiratory one-way valve. This whole area is fresh gas inlet. Basically, it is a site of delivery to the breathing circuit. Next we have is inspiratory one-way valve. Inspiratory one-way valve functions during inspiration. One-way valve opens, allows gases to move from fresh gas inlet and reservoir bag to valve into inspiratory limb of the breathing circuit. During expiration, it is closed, preventing exhaled gases entering into inspiratory limb. Okay, let me explain you what is this. This is expiratory one-way valve and this is inspiratory one-way valve. During inspiration, this gets closed and this is open. So the gas, because the gas will come here, it will go there and it will also go there. But since it will come here and expiratory one is closed during inspiration, so it will not move further over here. So it will basically actually move to this direction into the patient mouth. So during inspiration, one-way valve is open, but expiratory valve is closed. But when the patient will exhale, the reverse will happen, and we will see that in the next slide of expiratory one-way valve. So when it will function, what will happen? During expiration, this will stay open, and inspiratory one way valve is now closed. So the patient will breathe out. As the patient will breathe out, the gas will go there and there, here too. So but from this side the gas will come here, and since it is closed, so it will start to move from there into the carbon dioxide canister, and here all the carbon dioxide will get absorbed, and the remaining gas will come over here, because the remaining gas is like bit of the oxygen and nitrogen. So carbon dioxide will get absorbed, and during inspiration the reverse happens, and we have seen in the previous slide. So I hope you have grasped the concept of expiratory one way valve and inspiratory one way valve. These are basically unidirectional valves, and because of that this is called as expiratory limb and this is called as inspiratory limb. Next we have is a pop-up valve. Pop-up valve is a very important thing. It is also called as adjustable pressure limiting valve, overflow valve, or pressure relief valve. APL is basically safety valve allowing excess of the gas to escape from patient circuit. So it allows excess gas from the patient circuit to escape. If the valve is functioning properly, gas should escape if system pressure exceed 1 to 3 cm of water. So if the gas in the system, its pressure increases from this 1 to 3, the gas should start to escape. So normally it is left fully open during the surgery unless PPV is used. Basically, you should know that normally this valve remains open because continuously animal is breathing during surgery, and the pressure will definitely increase, and the excess gas keeps on going outside the circuit. But there are very few times when very few times when pop-off valve is closed. That is when positive pressure ventilation is used, but I am not going into the detail of PPVs because because if I will get into the detail of this, you guys will get confused. And as far as like simple exams like BCSE are concerned, you need not to dig deep into these things, because once you will be in practically using the this anesthetic machine, you will see and you will understand this. But you should remember that normally pop-up valve should always be remain open, except there are few conditions where pop-up valve is being closed. But after closing you should have to reopen it again, because if it remains closed and animal is under surgery, it can cause your patient to die. So so far over here, just remember that pop-up valve is a adjustable pressure limiting valve. It adjusts the pressure, it allow extra gases to move out of the circuit, and it should remain fully open. Next is breathing circuit. Breathing circuit is basically made up of corrugated plastic or rubber inspiratory or expiratory limbs. The corrugated tubes help prevent kinking and allows for some expansion if breathing circuit is subjected to compression or traction. And these two breathing limbs are connected with a Y piece that connects to the endotracheal tube or face mask. Okay, what are they saying? That basically we have this expiratory limb and this inspiratory limb, which is connected to a Y-shaped tube. And here it is either like this portion is either connected to the face mask, in which the mouth of the animal is placed, or it is either connected to the endotracheal tube that is then injected into the patient's trachea. So these tubes are basically corrugated, like they are not straight, rather they are like this. Why they are made this? Because if the tube is simple and plain and it gets bent, so what will happen? We know if by even by mistake the tube gets bent, there will be blockade of the flow of the gas and animal can die. But if the tube is being kinked, and after it, if it gets kinked or compression up is being placed, still there will be some how the play somehow space will be created for the flow of gas from one side to another. So it is safe way to use corrugated tubes rather than plain tubes. So that was all about the components of the anesthetic equipment. I hope you have understood all. Thank you so much.